More practice with end behavior. Before I give you guys the answer, before I talk about the answer, no matter what, you're going to have to describe the left side and you're going to have to describe the right side. What is happening as x is going to negative infinity, which is the left side, and what is happening as x is approaching positive infinity, which is the right side. So I'm going to write that for both of these because we are always going to have one approaching negative infinity, one approaching positive infinity. And then for the left side, we're going to describe the graph as going up or down. And for the right side, we're going to describe the graph as going up or down. For this one, same thing. So no matter what, for both of these, whatever your answer is, you're going to have that stuff written. How do you know? How do you know which is up or down? Here's the x-axis. Left side goes to negative infinity. Right side goes to positive infinity. Here's your y-axis, or your f of x axis. We could also call this f of x. Up is positive infinity. Down is negative infinity. Okay? You guys still with me? Okay, so this degree, the highest exponent is right there. It's that one. It's 4. So we have an even degree. That means both of these are going to be the same. It's going to be up, up, or down, down. All right. Now, what is the leading coefficient? Is it positive or negative? The leading coefficient is a positive 1. It's the number right in front of this term. Notice I don't care about the rest of the stuff. I only care about the term that has the highest exponent. So because it is positive, we know we're going up and then up. Remind you guys of our table. Let's do positive LC right here. Let's do negative LC right here. Let's do odd and let's do even. These are degrees. Okay, so odd goes opposite directions. That's your n. Okay, and then if you have a negative leading coefficient, it's going to switch. It's going to go up, down instead of down, up. So down here for the even, those are your u's. So if they're positive, then that means it's up, up. So I put my corners up here so I know the end behaviors are up, up. And then if your leading coefficient is negative, then you're going to go down, down. Okay, so let's use our table for this next one. Is this one odd or even? It is odd. So we're using the top row or the bottom row? Top. Oh yeah, I wrote odd right there. Okay, is the leading coefficient positive or is it negative? It's positive. So boom. It's down then up. So what do I have to put for this one, for the left side? Down. So down would be negative infinity. And then this one would be positive infinity because that's the right side. So left side, right side. Okay. Let's recap because someone asked a good question. I know this is odd. Why do I know it's odd? Well, I don't care about him. I care about him. He has the highest exponent. So because the degree is 5, and because the number 5 is odd, the function is odd.
Does that apply to all functions?
Yes, it applies to all polynomial functions.
So I could just do that instead of the negative x test?
Yeah, you can use that instead of negative x test. Now the negative x test tests if it's an odd or even function, right? But it also tells you if there's symmetry about the y-axis or the origin.
But you know.
The negative x test does both. Now we care on this in this scenario. We care only if the function is an odd or an even, in terms for the end behavior.
Yeah.
Just because you say a function is odd doesn't mean it automatically has symmetry about the origin. We have to actually test it to see if it works. All right, good question.